equal to 2, but it's on our square. So here we can see this is cosine. So t1 squared plus t2 squared, and then this is dt1 dt2. How can we solve this kind of question? If you are given the same random variable as what we have here, how shall we try to solve this problem? Any thoughts for this one?
I would say integrate one piece and then integrate the other.
You cannot split this into two parts, right? Because it's inside the cosine function.
Mm, maybe we can do angle formula.
Nah, that wouldn't do it because you still have the T1 and T2 who just multiplied.
Okay, what did we learn for Monte Carlo as Monte Carlo methods? So you're just trying to, instead of consider 1D case, let's do it x is like 2D, like the standard normal, but on 2D case, the density function is still 1, and then we just need to construct this phi of x, and this one is not too complicated because it's kind of like 2 times for each dimension. Is that okay?
Right.
But the difference is here, what is the determinant of the Jacobian matrix? Because for 1D we have 2, but here is 2 dimensions, so here we should have 4.
4.
Is that okay? So
Yeah.
we have 4 here, and then let's try to play with here. Okay, let's consider we have some u. It still follow the uniform, but this case is the squaring. Then this u actually is a vector, okay? So you can consider it's a vector. We have u1, u2. And then we still try to do a mapping from u to t. Then this time we consider this t is also a vector. Okay, this is a vector. Let me try to add in a row. So this should equals to 2 times this u, and u is also a vector. So actually can consider is t1, t2. Okay, so 2 different dimensions here. Excuse me. Okay, and then this tells us the Jacobian matrix will give us 2, 2, and that's on the diagonal, and then, excuse me, we will have the integral change too. Okay, we should change it to 0, 1. And here, T1 is 2 U1 plus 2 U2. Okay, and don't forget the Jacobian matrix, the determinant of that. Okay, then we have what we need here. Then what is our F?
Your F is 4 times cosine and 2 times U1 to the power of 2 plus 2 times U. It's a 2 to the power of 2.
Thank you, Claude. Okay, and we know the density function is 1, so we should have that. So this is our F, and then we can rewrite this as Monte Carlo estimator. And be careful, this U is our vector. Okay, should have U1 and U2. Then suppose, as I said, we have 4 different values. So you're being given some, let's say, xi follow the uniform distribution 0, 1. Okay, and we have like this. Okay, just let me use our similar values we have, but it doesn't matter. I can try to generate. So suppose you are given these 4 different, like uniform random numbers. Then I ask you to construct a simple Monte Carlo estimator for this new mu here. How can you try to do that? We already have this, right? So this U still follows the normal standard, not normal, standard uniform distribution, but it's 2D case. So here we know this are all IID. Then we try to construct our 2D case. Say, for example, we can consider, based on what we have here, we construct 2 vectors that follows the standard uniform distribution, but on 2D case. Say, let's have this one. So 3, 0, 2, 7.2016. This is like U1 hat. Okay, not hat, the vector. And then we have another one. And this is 0.7022, 0.2631. Then we can just plug it inside. So right now, what is the sample size for this case? And is exactly equal to 2, even though we have 4 random numbers. Whether interval changed from 0 to 2, 0, 1, because we do a change variable transformation. Because U is from 0, 1, T is from 0, 2, so we do the change of variable, so we have this 4 comes out. It's just similar as this case. So from A to B to hypercube A to B to 0, 1. Yeah. Okay. Yeah, feel free to ask if you have any question. Okay. And then n is 2, then we can get this mu hat actually with 2. So because we have the sample size is 2. So it's 1/2, okay, 4 times the cosine, 4 times 0.3027 square plus, okay, and add another one. Okay, then you can do the calculation. That's the answer you have. But maybe you are asked, for this example, can we do something just generate the uniform distributed on 0, 2? Yeah, of course you can do that. Just when you're given this, you're trying to stretch it to 0, 2. So multiply to 2. You can still do that. But when you do this, don't forget the density function. So if it's 2D case, 0 to 2, then the density function is 1/4. So you will still have this 4 occur. So no matter how you try to do it, this 4 will always occur for your integrand. Is that okay? This is what I want to show you. I think this is important to play with this. You know why we can convert this integral to the Monte Carlo simulation is because we consider that's the expectation of some continuous random variable. And then we just try to generate this variable first based on the density function, and then we have this f. Okay? Any questions? All right. Then I can make it even more complicated. Okay, so this time I try